All right, in this question, I'm going to show you guys how to solve another trig equation, but this time with a double angle. And what I mean by double angle is that your argument on the cosine ratio here is two times theta, not just theta anymore. So this process involves a couple more steps than usual, but first thing you want to do is, of course, isolate the cosine ratio here. So to isolate the cosine ratio, the only thing I need to do is bring over the 2, so therefore cosine 2 theta is equal to 1/2. So what does this 2 theta mean then? We actually have to manipulate our current domain so that it fits the double angle here. So instead of theta, we should actually be writing it as 2 theta in my domain. So what I have to do to get 2 theta is you have to multiply each component from my domain by 2. Okay? So I end up getting 0 times 2, which just gives 0. Theta times 2 gives you 2 theta. And finally, 2 pi times 2 gives you 4 pi. So what essentially happens when you double the angles, you're actually doubling your domain. So instead of going once around the circle, you're actually going twice around the circle. So let's go and look at the unit circle here and find out where my solution is going to lie. Now remember, we're looking at values for theta, or 2 theta I should say, where your x value is 1/2. So looking at the unit circle, cosine will be positive in 2 quadrants. So using add sugar to coffee, cosine is positive in quadrant 1 and in quadrant 4. So where is cosine 1/2? So you'll see here on the unit circle that we have cosine 1/2 at exactly pi over 3. So that's my first solution for one rotation. And then my second solution is at 5 pi over 3. So that's that terminal arm right there. Now remember, that only takes care of one revolution, but we need 2 revolutions here. So far, this is what I have for my solutions. 2 pi is equal to pi over 3 and 5 pi over 3. So I need to consider another rotation here. So for example, for the first solution, pi over 3, I not only need to consider one rotation, but a second. So to get that rotation, remember the idea of coterminal angles. They share the same terminal arm. To get a coterminal angle, you add another rotation, which is 2 pi in this case. So looking at my fractions here, the next solution is going to be 7 pi over 3. Okay, so that's the next solution here for that second rotation. And then of course we still have another terminal arm to work with in quadrant 4. Okay, so right there. So we already went once around the circle, but we need to go one more time around. So once and twice. What would that angle be? Remember, it's coterminal angle again with 5 pi over 3. So to get an angle coterminal with 5 pi over 3 in one rotation, add 2 pi. Okay, so you'll see here I get 11 pi over 3. So that's my next solution. Okay, but we don't want to find 2 theta, we want to find theta. So to get rid of the 2 in the front, we divide every solution here by 2. So my values for theta are as follows: pi over 6, 5 pi over 6, and 7 pi over 6, and finally 11 pi over 6. Okay, that is how you do a double angle trig equation question.